appreciate
Summer.
the pool better.
I'm
The
excited
pool
for
more.
No,
I appreciate the
excited.
pool.
I like that.
Summerman.
Mick just moved to the other
I'm
side.
sad, but like I'm sad about like not having you next year, Mr. Hudson. But other than that, I'm like I need to leave this place. I want summer already.
Exactly.
But I'm gonna be so sad.
So this is not on your paper. I hear you, but we'll go too far down the rabbit hole if we keep that conversation going. If I don't know, quote unquote, don't know any of the, I know angle A, angle B, angle C. What is another way that I could say what angle A is? Like the size of angle A. Guys, that's what this symbol, all mean the same thing. And like some people, as I was working on homework, I was like, oh, we didn't talk about this. That means measure of angle. Like that's not less than symbol, that's an angle symbol. Guys, the less than versus the angle symbol normally just has a flat bottom, right? As opposed to the less than symbol does not have a flat bottom, it's more like a V turned on its side. So, the other way that I think makes more sense, because when you're writing, it's quicker to draw. Instead of M of angle, this means like how big is the angle opening, and you could either just arc inside of it, or your arc is allowed to go like bigger than the angle symbol. All of those symbols mean the same thing. Sorry, I might as well show it. You could also just keep it on the inside. But all right, so angle A. How do we talk about how big angle A is? Well, what do we know about any triangle, no matter what? Any triangle. Alex, what do we know about any triangle?
All the sides, all the angles add up to 180.
All of the angles add up to 180. So I could say A plus B plus C, knowing that those are the angle measures, right? That's why I don't have to put those other symbols. You can if you want to. 180 degrees. Okay. So if I want to talk about how big angle A is, Will, do you know how we could talk about how big angle A is? If we know all of them together are 180. Don't try to give numbers. Use what we know. And if we don't know any numbers, don't just make them up. What are you trying to say, take away? What are you looking at?
If it's 180
If I'm looking for angle A, and we know ABC are 180 together, you can pass this off too. You don't have to pass. I mean, that just means your card goes back in the deck instead of in my pocket. Ahmad?
You can A would equal 180 minus B minus C.
Ooh.
B plus, wait.
You could do it either way. Trying to interrupt people, Maddie, and I'm writing the wrong thing. What he said is correct. You could either do 180 minus B and then minus C, working left to right, or add B and C together, take that away from 180. So as you're working on this one, keep that in your head of we can figure out, like we know what we know the 180 degrees always. And also, what else is always 180 degrees? Simon?
Like a straight angle.
A straight angle, right? It's straight angle. Isn't that like an oxymoron? But yeah, a straight angle is also always 180 degrees. Take a couple minutes, figure all this out. You might, if you're struggling, you might want to make a table. Because we all always have graph paper out for math class. You would have space to do this. If you want to make a table like that, go right ahead.
Which angles are we still doing?
All of them. Every single thing that's missing. All of them. Every single piece that's missing. We need that one also. If you get all four of these done, you can go ahead and start trying to work on some homework if you want, if you know what you need to know. If you didn't turn in the homework before break, please do so. tried to work with your peers yet?
You first tried to be stringy.
Then work all three of you, or all five of you. Ask for more help from you. You do not go straight to asking me for help.
Well, what did the saying neighbor was
I'm guessing that
Guys, some of you are making this way more complicated than it needs to be. Give me your attention for like 20 seconds. None of these letters matter
Oh.
unless you're going to use a table. And then we could say this is angle A, this is angle. But unless you're going to use a table, none of those letters matter. We're just trying to figure out the unknown size of the angles. So like for this one, which we could call angle C, but that's kind of annoying because like, well, which one is angle C? The one on the inside or the one on the outside? Ada, how could I figure out the red arc that I put? Like, how could I figure that out? Oh, you know this. I'll let you pass, but you know it. Ella? Or
Yeah. So you know that like the line that you highlighted in green is 180 degrees, and you know that like the angle on the outside is 56 degrees, so you can just subtract 180. You can do 180 minus 56 degrees to get the angle of the line.
Ada, tell me what Cora just said.
You subtract 56 from 180 to get the red.
See, you knew what to do. Because if Ada or Cora knows and you guys are partners, my bet is that you talked about this. So yeah, if you don't know how to solve that angle, you might want to jot a note on your paper. 180 minus 56, because we know the straight line is 180. So 130, 124? 124? Alright, keep going. You also know the inside of a triangle is always 180 degrees. I'm not answering any questions right now.
So I just want to ask, what are we solving for the outside too?
So is this an angle? Yes. We are solving every unmarked angle. Like any angle that's formed, we need to figure it out. Make sure it makes sense. Because I see a like here, look at my paper happening. Simon, if we know that 124 now, how can we figure out this angle A, quote unquote, if we call it angle A?
If so, like the inside C angle is 124,
Yeah.
and we know like all of the angles in a triangle add up to 180. We have two of the angles, so we add those two, 124 and 20, to get 144, and then.
You're right. I'm just writing down what you're
And
saying.
then we do 180 minus 144 to get 36.
Yeah, Simon says add up the angles inside the triangle that we know, which are the 124, because inside the triangle, and the 20. That's 144. We're going to take that away from 180 because we know the whole triangle is 180. And that's going to leave us with 36 degrees. It's probably going to be that temperature on Wednesday, Thursday. I forget, but it's getting back down to freezing. Sorry, guys. There's a chance of snow in the forecast still. Ohio! I'm not, this is not April Fool's, I'm not joking. I planted grass over break and I'm a little scared because if it gets down to freezing, that's not great. But, Gus!
when am I supposed to solve?
Anything over here that you want to.
I'll do figure 2 and I'll
Do you want the one out here or do you want the one up by B?
I'll do B.
Okay. Better than if you said I'll do D. Ha, poop. Okay, Gus!
Okay, so you know that like the one next to A is 90 degrees and it's the right angle.
Hell yeah! This means 90 degrees.
And if all angles in a triangle are 180 90 and 33 together and minus them from 180 to get 57 for like the one next to B.
57. Guys, let's get in the habit of putting the degree symbol on there. A lot of people won't mark it off for that. If you're doing Desmos or Khan Academy, a lot of times the symbol's there for you because typing it's kind of a pain in the butt. But let's get used to writing it.
That's what happened in 4th grade and 3rd grade with periods. Like, I would never end my sentence with a period.
All right, so this angle, Owen, gonna help me with that exterior angle. By the way, guys, what we've been saying, we've been leading a word off of the interior of a triangle is always 180 degrees, right? And, like, I know that you know that, but let's, like the symbols, let's practice the vocab. The interior is 180. So this exterior angle, how can we figure that out?
That angle would be something interior to the 33.
So how do we figure that out?
We subtract 180, or we subtract 33 from 180.
And what do we get?
We get 147 degrees.
Thank you. All right, so figures 3 and 4. Vivian, you get to pick. What do you want to solve for in figure 3? The interior angle or the exterior? You could do the exterior right now. I bet most of you are saying, no, we couldn't. You could do this, and you could figure this out right now. If you paid attention to figures 1 and 2 and spotted the little relationship. But if you haven't spotted that relationship yet, we should probably do the interior. So you decide. You should do the interior. Yeah. All right. How do we do that?
55 plus 27 180 minus
70, 80, 82? So then what's left over after 180 minus 82? 98? 98 was a band from the early 2000s. Nice boy band. Not as popular as NSYNC or Backstreet Boys. This is why you probably don't know 98 Degrees. But there was like NSYNC and Backstreet Boys. And then there was like O-Town and 98 Degrees and like some of the other lesser known boy bands. Sorry, there's your pop culture for the day. All right, so if that's 98 degrees, then what is this angle? Wait, hold on. What did we just say is 98 degrees? What was Vivian solving for? The interior. So wait, we just found that, hey, this is why we do math in pencil. That goes here. My bad. I was just getting excited about showing you guys the special rule and talking about, boy bands from the 2000s, because who doesn't want to? What's this angle then? Anybody? No, you guys said 82 was the sum of the other two angles. I want the outside angle. No, you said 82 was this and this. I'm looking for that.
That's the exact same.
What, Beatrix?
That's what the rule is.
What's the rule?
You add, so for this example, you'd add 55 and 27, and that's what the exterior is.
Any. We call these remote exterior angle of a triangle is the sum of the other remote interior. So essentially what we're saying is the one you aren't touching.
Pardon the interruption. Lane Bergen.
Stick with me. If this doesn't make sense yet, watch it happen. If this is 136, 80 with me because you're halfway to a nap. This has to be supplementary. So I know it needs to add us up to 180. So it would be 44 degrees. But then these three add up to 180, which means I need to do 180 minus 21 plus 44, Which, or if I do 136 minus 21, I should change the color. 1, how much? 15?
115 degrees. 150 degrees.
The exterior angle is equal to the sum of the remote interior. Let me double check. Did I put this in the math notes? I think I did. Anyone find it in the math notes yet?
I think I did. I just don't know how I know. You know, I was looking at them during, like, I was looking, I was like, math notes. And I was like, kind of looking at them.
So check it.
See,
Exterior angles, right? When you just extend one side of your triangle. Both of these could be exterior, but it gets a bit more complicated to look at like which one. That's not an exterior because that's vertical. It is not just an extended. I could draw an exterior if I draw this angle up here. This angle could be exterior to the triangle. This, come on, they didn't even, like, come on, who did that? That's not even extending one of the lines. Same thing here, that's not extending one of the lines. They just drew like a willy-nilly line. So, an exterior angle, yada, 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 remote interior angles. All the remote interior means is the other angles you're not touching. So if you look at angle 4, what is not one of the remote interior? Angle 3, because it's right next to it. So what are the remote interior for angle 4? The other ones it's not touching, and the sum of these will equal that. Yeah, Alex?
Also, I don't think we solved for every possible angle on the questions, on the previous questions. We still solved for the exterior angles.
Well, if we draw more lines, we got that one, 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 that one.
Just do 300. We just
Well, okay, yeah. So we normally talk about angles in their under 180 degrees form. Once we get past 180, like, and that's just normal, right? Not that we never go above 180. Like, so you're right. So I was unclear on that of like, we just want to solve the actual angles that are. So what Alex is saying, if anyone can't see what he's saying, is we could solve this, but it's kind of silly because we know it's like 360 minus 150. Like we could, but we don't need to do all those. Especially up here, this just gets kind of messy of like, why would we be looking at that angle? And we might, depending if we're planning a park with a fountain or something, like, we might look at that angle, but we're probably looking at the angle inside the triangle. Questions on exterior angles? Take like 3 minutes to look at a homework problem and solve it knowing what you know now. This is in your math notes. I just showed it to you. What?
Earlier you explained this symbol, but I also didn't really
The
understand.
measure of angle. So it's essentially just saying how big it is. So this is saying the size of angle 2 is equal to the size of angle 7. No. The size of angle 2. Angle 2. So we can name angles with letters, or we can name angles with numbers. We can name angles with anything. You could say angle elephant if you want. So angle 2, this is angle 2.
It's just saying
The size of it. We don't know how big it is, but however big it is, so is angle 7.
it's basically just saying it's just stating it's an angle.
It's like calling it Alex. If we named this Alex, we could then say Alex equals, maybe we named this one Owen, or wherever, like, so we'd say Alex equals Owen. Like, we just are using numbers for names, right? Literally, you could call it whatever you want. It would complicate. You could say, like, green, blue, purple, red, yellow, indigo. Like, you could call them whatever you want. Right now, we're just using numbers. Mm-hmm. Yeah, so this is exactly what Alex and I were just talking about up here. Guys, these are just measure of angle 2. So it's saying the size of angle 2 is equal to the size of angle 7. So if you get told angle 2 and angle 7 are equal, does that tell you anything specific? Yes, it does. About what lines are parallel? Like, of course, yes, it tells you that they're equal, but does it tell you anything about what's parallel? Yeah, it does.
That means 10 and 15 are parallel.
So the line names, again, Maddie, I would ask you to not just shout things out. The lines A or C, D, E, F, that's what we're trying to relate to each other. So guys, let's do this real quick together, because now I'm scared. Especially because Maddie shouted it out, and if you listen to Maddie, what she said is wrong. Sorry.
Oh no.
Okay, maybe I should say that differently. Not necessarily what you said is wrong. What you said is not what we're looking for. So what you said might be right.
That makes me feel
What
a
you
little
said
better.
might be right. A little better, right? If 2 is equal to 7, if 2 is equal to 7, we just found alternate side, interior. So what does that tell us? That these lines are parallel. So you would write C is parallel D. That's the parallel symbol. And knowing what we just figured out in this lesson, you should be able to solve all of these. And I'm checking if there's actually anything else I really want us to do today. Yeah. Although I'll let this be... All right, let's do one more together, then I'll let one be your option. I actually want to start all 3 of these. Take a moment, pause what you're doing, put your pencil down. Look at A, B, and C, and just ask yourself, what would be the first thing you write or think about to start solving in that situation? So, for example, like in A, Maddie, based off what you see, how would you start A?
Figuring out which variables I have. So then it'd be so then I would have 3x plus 2x equals 5x. So then I would do no, that's wrong. Wait, no,
No, that's right.
So then I would do 130 minus 180 divided by 5 to get the x.
Back up. There's no 130 here.
Oh, sorry, 135.
So hold on. Maybe we might need to tag someone in to help. If 2x and 3x, I agree, add to 5x.
Yeah.
Math, 2 plus 3. Claire, can you help us with what we can relate that 5x to?
Well, doesn't the 5x, wouldn't that equal 135?
Those remote interior angles equal the exterior. So you could set up 5x equals 135 and go from there. Laurel, what about B?
She's not here.
Oh, yeah, I knew that. Her mom emailed. She's on a trip. I'm jealous. Beatrix, what about B?
So I would probably, how 160, so I would do the, other side of that.
We could.
I know you're supposed to do the other thing, but that's what came to mind first.
You're totally fine. You could. So we could do this angle, right, and then go from there. Or if you want to use the thing we just learned today, because, why not use some new stuff? The 167 should be equal to these put together. Can I do 3x minus 1 plus 21? Yeah, but the 3x can't add with anything. What's negative 1 plus 21? 20. So we get 3x and 20 equal what? The 167. Now you could, though, take the way that Laurel's gone. Take the way that Beatrix said, we can figure this out, then we can add these up and figure out what this has to equal, and we can do the algebra. You can.
49.
What?
49. I think. X is 49.
want to see who wants to step up to this challenge. Totally optional. Only if you want to, but I will say this is where Dr. Smith's advice comes into play. Anyone listened enough this year to know what Dr. Smith's advice always was? If you don't know what to do,
Yes. Don't do anything else.
say it louder, Amir.
Do anything.
Do anything. Give me an example of an anything we could do here. And if you don't have one, we can pass. We've got other hands up. Ooh, we could do a supplementary. So what could we figure out based off supplementary? Sure, so what would be here? 159. Thank you. And, oh yeah, that's a nice one. 95 degrees. Okay, Gus, was that the anything you were going to give me?
No, I was just saying I have to make a line from like to make a triangle.
Do you want to come down from top left or come up from bottom left?
Bottom left.
Bottom left? Guys, look up here real quick. This is where, like, Dr. Smith, just like, he just became my favorite professor over time, but, like, these moments of, like, oh, we could do this. And we could also, if we really want, well, this is kind of obvious that we could do that. Could I also do this? If I draw that better. Yeah, wait. Give your brain time to think. What other relationship can I figure out now?
The angle to the right of the 21.
Your next words are about to say, look.
Isa Raleigh, please come to the Perry office. Isa Raleigh, please come to the Perry office.
Alex?
You can find out X now.
Can we? Talk me through how.
180 minus 21, because that should be a straight line, right?
Wait, 180 minus 21. So you're looking at that 21, this here.
But also because of the angle relationships, you can figure out that 21 is also.
21 can also go here.
Wait, can it also go
I have an answer for you if you want to stop by.
The opposite? I forgot.
Can it also go where?
I forgot what kind of angle it is. But
Or you can call me from any phone. I'm forward of
exactly opposite to it.
So this is alternate interior, right? The 21 and the 21. I don't know where else, but like this will let us get to X. Now, like you said, let's get to X. We're almost there. Because now that I know 85 and 21, can I figure out this? Yeah. We know we have to add up to 180. Now be careful. I don't think it can be 106. Oh, you're talking about the X. Sorry, yeah, we're not ready for the X yet. What was... So in here, Mick said is 74 because we got to add up to 180 inside the triangle. 74 degrees, right? So then X now, again, adds up to 180. So, yeah, and Mick already said it, is 106. I don't have enough colors, I feel like.
Which would also make the angle on the outside.
Ooh, and vertical angles, right? Vertical angles would tell me 106 also that... Wait! Vertical angles! Vertical angles! What's that? 74! Wait, where else can I draw 95? The bottom right! Guys, when we first looked at this image, did you think like, screw it, I don't want to do that challenge in my home? I guess maybe I should ask a different question since this is the class of like, yeah, bring it at me.
I just wanted to go to the board.
You didn't even ask. So,
I know.
guys, that Dr. Smith advice like I hope will stick with you as you go like through your math career of like, if we take this all the way back to the original slide. All right, from here, I don't know that we can figure out anything except for the 95. Well, okay, and so we did boop and boop. But then, without drawing lines, can we figure anything else out? No. Like, I don't think we can do anything else. Guys, for real, I don't think we can do anything else with this image until we start saying, I'm allowed to add to this image. I can do whatever I want. So I start doing what I want. I extend that line. I extend that line. I extend this line poorly, and then I fix it. Now I've got triangles. Now I've got parallel lines with transversals. I know triangles are like, once you start, it just snowballs, and it keeps going. What can I do now? What can I do now? What can I do? And eventually you're just like, holy crap, I didn't even need to do all that. We were just trying to solve for X. But we can. All right, have a great day, guys.
Woo!
Oh, I saved it on the original. That was wrong. It's I just saved in the wrong file location.